Alright, again, this is going to be another teaching aid for AutoCAD Fusion, and I need to make a disclaimer because this is the uh, in the process of recording the first video. I lost power to my house, therefore my computer, therefore I lost all the data I was working on the first original drawing. So the drawing we're working with now is actually not the original drawing that's in the presentation. I have made a note of that, and it's not going to affect anything. You'll just see that some of my drawings are not quite like the others. All right, so on slides 12 and 13, you'll really see the difference between the two drawings. All right, so hang on one second, my phone just went off. All right, so put this down. All right. So here we are doing isometric drawings. Isometric drawings are like projection drawings, and you'll see here this is not the original one. Oops, I need to delete those lines real quick. Bless me, sorry. This is not the original drawing, but this is what the drawing that the dimensions are based off is. So this is it in 3D view or 3D modeling world, and this is it in isometric. Now here I put the actual isometric view and then two different projections of it. So what you're seeing here is both all the dimensions, hopefully this time, needed to draw it. And let me come here to actually demonstrate what you're looking at. So here's the 3D view, and if I hit this front view, you'll see I'm looking at it like this, right? Which is the same as what I'm looking here, except you can see this hole, right? This is why we still have isometric drawings around, because you still see more detail in these than you can in just 3D modeling world. And the same thing goes for the right view. If I turn it this way, I can still see, this side, but if I come here, I can see all of this data plus the hole that's going through the middle here. And note that the hole is represented by dotted lines there. So hopefully we have everything we need to draw this again. So let's draw this again. Alright, so in general, at least the way I usually draw things, I usually start from the top up. You can draw, I can start from here and work my way down if I wanted to, or at this circle and work my way down, but it's just easier for me to start from the top up. So here, close this. We are going to get back to that, but not right now. Alright, so first thing I want to do is I want to dimension this triangle, which is the base. Alright, if I come here to my drawing, I see that it's what, 50 by 55. See, I'm looking at from one side here and the other side there, so 50 by 55. Sketch dimension. This is going to be 55 millimeters, and this is going to be 50 millimeters. Alright, so there's my first drawing. So I'm going to go ahead and extrude that here, and this I already know that it's 10 millimeters. And because hopefully it's not going to crash on me this time, I'm not even going to look on the bottom side. I'm just going to keep drawing. And come here, back up to rectangle. Make sure you select this top face. Here. Here. Okay. So this extends out. And here. Alright. So I'm going to do something. This is where I'm going to start using a constraint, or a relationship. So I kind of drew this one a little bit oblong, right? Or you know, it's not. This one is actually a square, right? And the reason I know it's a square is because I can see two different views. I see this is 25 millimeters, and it doesn't put a dimension here for this length, which is this side, right? So here I can make the assumption that it is a perfect square. So instead of dimensioning one side versus the other side, I can actually set a relationship called equals. So I hit this little sketch palette over here, like that, and hit equals. So I'm going to click this, click that, and now both sides are equal. Stop sketch. Assembly. Now we're going to press pull, and that dimension is 20 millimeters. I'm looking at the dimensions on my other screen in case you were curious. Alright, so there's 20 millimeters. Now I'm going to draw the square that's this one. Right, so I'm working from the ground up. I just drew this one. Now I'm going to draw this one. Alright, so this one, notice that, let me see, there it is, right here. So the only dimension I have right here is this 5 millimeters. It doesn't actually tell me how long this is because I already know that this length is going to be, what, this is 55 millimeters, so this is 25 millimeters, so take that away, and then I have whatever's left here. Alright, so I know that this is attached to this part, is all one piece. So I'm come back here, I'm going to draw that with the set dimension in there. So sketch, rectangle. Select my surface, draw my rectangle, making sure that I'm hitting this line here. Come back up, click, alright. Now I just need the dimension from here to here. So I'm going to press escape, right click, sketch dimension. I'm going to just click here, and it doesn't like that, so I'm going to hit escape. I'm going to click over here a few times. And here I'm going to put 5 millimeters. There we go. Alright, so now I'll press pull this, hit that, and that dimension is also 5 millimeters. So hit 5 millimeters. So on the circle, on that little peg I put off to the side, let me show you. This one. Now here I have really nice clean dimensions for it. Let me see if I can demonstrate. Yeah, here I have, you can see I have 5 by 20. So it's 5 millimeters from here and then 20 millimeters from here. However, when I was doing it in here, it did not like me putting dimensions that like that for some reason. I tried every which way I could. But that's okay because it gives the students a chance to do some math, because in a lot of the drawings that you'll see is they'll leave dimensions out because you can figure that dimension out from the other dimensions present. And that's kind of what I did here. So for that circle, I know that that circle's diameter is 6.32 millimeters. Why did I make it 6.32 millimeters? Just to make it so it wasn't a nice even number. And I also did it before I realized that was going to give me these issues. So, but it still works out. So here, 6.32, enter, enter. So now it's 6.32 millimeters, but we still have to define it this way, this way. Now from the drawing, you can't, it's not really clear what this dimension and this dimension is. But what it does give me is the dimension from this edge here to this edge here. So let's do that one first. So how do I figure that out? Well, come back here. And I could probably do something with the radius, right? Because I know the distance between here and here, right? But I don't know the distance between here and here, yet I know the radius is 6.32. Alright, so you take 6, or not the radius, the diameter is 6.32. So I take 6.32, divide it by 2, and I get 3.16. So if I come back here, so if I take 8.16 minus 3.16, I should have that dimension, right? Makes sense. 8.16 minus 3.16. So I'm taking the distance between the diameter in here, and I'm minusing the radius here, so it'll give me the exact point there. And that should give me 5 millimeters. So come back here, I'm going to dimension that dimension. There, nope, didn't like that, so I'm going to hit escape, escape, click, click. Let me get rid of this because it's confusing me. Alright, so click here, click this dot, and I'm going to enter 5 millimeters. There it is. Alright, so now I need the dimension from the radius here to here. So come back here, I'm going to do a similar thing. So for right here. So I have the dimension from the diameter, the outside edge of the diameter to this edge, and I have the diameter of the circle, right? So the only thing I should need to do is take the diameter away, or I'm sorry, the radius, or half the diameter away from here, it gives you the radius, and that will give me the dimension from this radius to this point. Right, now I know it's 3.16, so if I take 23.16 minus 3.16, it gives me 20. Alright, sketch, sketch, here, here, here. 20 millimeters, there we go. So there is, that's fully defined now. Alright, so come back here. I'm going to come back to my thingamajig. Now another thing to point out is generally in all these drawings, there's some type of, to let you know what the units are here. Alright, so that is 5 millimeters, so I'm going to extrude it out 5 millimeters. And I know I keep saying extrude because I'm used to a different software. Here is press pull, even though it does have extrude, I found. Okay, so now we're getting close, right? Only thing we're missing is this hole right here. Okay, so this hole looks kind of complicated. However, there's an easy way to make that hole. It's called the hole tool. And to do that, now, one thing also to point out here is you see that it doesn't give me any dimensions around telling me the edge of this hole, right? Even over here, I don't have any dimensions. Now, in most drawings, you probably would have a dimension right there, right? But and also it depends on who's drawing it, all that stuff. But here, I can make the assumption that it's in the dead center of this because they didn't put any dimensions telling me otherwise. Alright, so how do I find the dead center of this? Well, we're going to use the tool that we've already learned how to use. It's called center lines. So I'm going to draw a line from here, here, here to here. Alright, so that gives me the dead center now. I have that dead center. I know exactly where it is. Now I'm going to turn both of these lines back into center lines. Alright, so they do that in the double click on the line, right click, normal construction, double click, right click, construction lines. I know I keep saying center lines. That's just what I'm used to calling them. But I mean, it's really what you use them for. Like find a dead center or something. Alright, so here, now here I'm going to come over here to the sketch palette and to grab midpoint right here. Alright, and I'm just going to click on one of these lines, and what that's doing is it puts a point, even though you can't see it, it's there, it puts a point right there at that midline, midpoint right there. So, alright, so I'm going to stay in this view because I think it helps. So I'm going to hit escape, close this, come over here to create, and come over here to hole. Alright, so hole, it's going to ask me where I want to draw the hole. Well, I want to draw the hole right here. Alright, so then, now it gives you several selections here. I have countersink holes, I have simple holes, and I have counterbore holes. So I use counterbore just to kind of show the difference um, between the holes, but typically the dimensions here would be whatever, like a screw. Like whatever screw you were going to use to stick in there, you would set the dimensions for that. And there's actually a really cool way of doing that here in AutoCAD Fusion, which I hope to get to in this tutorial. So grab this. You see how I have that dot right there now? Yeah, I don't want if I let go it. Yeah. So here I'm gonna grab this. I'm going to drop it over there, and it kind of snaps into place, so it hits the dead center. All right. So now I'm going to actually change my view a little bit just so I can see the hole. And I think mine are already set to, let's see, 2. I'm going to change that dimension right there because that's supposed to be to there. Let me do that right now. Delete. Annotation. Nope, I don't want that one. I want line dimension. Go from here, here, there it is. So yeah, 15 millimeters. The counter bore is not really counted because that's already set based off the other parameters. So come back to here. We undo what I did because it messed up. Hole pattern here. Select the surface. Drag this to the midpoint. There. So yeah, my depth is already set. Alright, this is my diameter. This diameter is this diameter here. Alright, don't worry about the tip angle, that's the bottom part down there. Counterboard depth, that's this depth here, right there. And then the counterboard diameter is this diameter. Click OK. And then delete these center lines, even though you don't have to, it just makes it look better. And you're done. That is the first part. Congratulations. Yeah, that's it.